2009 question 4, BC question 4. We have the differential equation dy dx is equal to 6x squared minus x squared y. And let y equal f of x be a particular solution to this differential equation with the initial condition f of negative 1 equals 2. And so the first thing we want to do is use Euler's method with two steps of equal size starting at x equals negative 1 to approximate f of 0. And show the work that leads to your answer. So with Euler's method, we're starting out with a point. We have an x and a y. Following this, we have our derivative dy dx evaluated at that x and y value. And that's our rate of change. Then we're going to multiply the rate of change by a small change in x, which is our delta x, and multiplying those two together gives us a small change in y. And finally, we add the delta x to our original x to get our new x coordinate, and we add the delta y to our original y to get the new y coordinate of our next starting point, and we go through the process again. So let's see what we have here. Our original x is negative 1 and our original y is 2. We're going to plug that into 6x squared minus x squared y. And I believe when you work that out, you get a positive 4, 6 minus 2, which is 4. The delta x is determined by the problem. We're going to do this in two steps of equal size to go from negative 1 to 0, and so it's positive 1/2. We multiply 4 times 1/2 and we get 2. X plus delta x is going to give us negative 0.5. Y plus delta y is going to give us 4. And those become our starting point for the next iteration and final iteration. So the derivative evaluated at x equals negative 0.5, y equals 4. And that leaves us 3/2 minus 1, which is 1/2. And the delta x is still 1/2. Our delta y is going to be the product of those two, which is 1/4. Now we're going to add 1/2 to negative 1/2, and that gives us 0 for x. And y is going to be y plus delta y, or 4 plus 1/4. And so our estimate is that at x equals 0, the function should equal 17/4. And that's the answer to part A. In part B, we're given the point, at the point negative 1 comma 2, the value of the second derivative is negative 12. We want to find the second degree Taylor polynomial for f about x equals negative 1. Well, the second degree Taylor polynomial will be f of a, which is f of negative 1, plus f prime of negative 1 times x minus negative 1, or x plus 1, plus the second derivative of f at x equals negative 1 times x minus negative 1, or x plus 1, all divided by 2 factorial. Well, we're given that f of negative 1 is equal to 2. F prime at negative 1, which is dy dx, given x is negative 1, y is 2, is going to be 4. We found this already. And finally, the second derivative at negative 1 comma 2 is negative 12 times x plus 1 divided by 2. And for the final adjustment, the exponent on that second x plus 1 should be squared. So it's 2 plus 4 times x plus 1 minus 6 times x plus 1 quantity squared. And that is our answer to B. We'll look at part C in the next video.